Okay, guys, welcome back, everybody. And let's go over this 3.3, and we talk about the slope of the line and rate of change. So here we are gonna, introduce what is the definition of the slope. So as you can see, when we talk about the slope, and it's either you want to find out how steep that slope is, it's very much you can use a percentage to see how deep the slope is. The greater the percentage, the steeper the slope is going to be. So the flatter the slope, the less or the least percentage you're going to be seeing. So in order to determine the slope, always you're going to have to find out the rise over the run. So the change in y direction, the change in the elevation divided by the change in the horizontal distance to find out what the slope is. So the slope can be expressed in ratio or in the form of fraction or in the form of percentage. So for this case, as you can see, we have a change in y, which is 8 feet, and then your change in x is equal to 16 feet. Therefore, the slope is 1/2. So you can express that as 1/2, or you can change the percentage, which is going to be 50% slope. So here is to determine what the slope of the aircraft when they take off the path, and given the change in y equal to 500 and your change in x equal to 6,000, we can use that formula. The slope is equal to change in x, change in y over the change in x. So your change in y, and you can see your y is 500 feet, and your change in x is 6,000. So you can simplify that, cross out the 20, cross out the 20, divide that by 5, you get 1 over 12. So your slope is 1/12. You can express that in a percentage if you want. You can use a 1 divided by 12 and determine what the percentage is. So I'm gonna clear that. Let me clear everything up, and let's go on to the next problem. But again, you're gonna practice this, and if you're not so clear about this kind of a question, bring that up to the Q&A live session, and then we can go over that one more time. So when we talk about that slope formula, we have the standard slope formula. We have m equal to y2 minus y1, x2 minus x1. So when it's given 2 points, and this 2 points you can determine what the slope for that line by using that formula. So that formula was derived from change in y over change in x that we learned, the last slides. So from here, and change in y is point y2 minus y1, and then x2 minus x1, and to find out what the slope is. And as you can see, if x2 minus x1, then the slope is undefined. So you cannot have that slope equal to 0. But if it's undefined, then we can say, there's when the slope is undefined, then it's going to be a vertical slope. So here, they want you to find the slope given that 2 points. So you can use that formula that we learned, m equal to change in y over change in x. Change in y is y2 minus y1. Change in x is x2 minus x1. And now you can substitute the point, and you have a -2 minus 3, and then you have a -4 minus -1 to find out what the slope is. And from here, you can see -2 minus 3 is -5. -4 plus 1 is -3. And here, because you have a negative and negative, you turn that into positive, and therefore the slope is 5/3. So yeah, so then you can plot that point, and if you have the 2 points, and you can use that 2 point, plot them onto the graph, and then connect this 2 point, and then you can see the change in y is 5 unit, and your change in x is 3 units. Therefore, your slope is 5/3. Change in y over change in x. Remember that the slope is always change in y over change in x. Rise over the run. Rise over the run. So here we have a slope that is going through a given point. With that 2 point, use that formula, m equal to change in y over change in x. Substitute, this is your x1, y1, x2, y2, and then you would just substitute that y2 minus y1 over x2 minus x1, and then you can get the fraction. And here they want you to find another point that is passing through the point. And this case, you're gonna deal with fraction. So it doesn't matter if it's fraction or decimal or what have you. Put them into that formula, m2 m equal to y2 minus y1 divided by x2 minus x1. So with that, you can see y2 is equal to -3/2 minus y1 is equal to 1/2. And then followed by x2 is 2 minus -5. Now you can see you have a -4/2, and then you have 2 plus 5, and therefore the slope for that 2 point is equal to -2/7, or you call it -2/7. So, and then you can, of course, with the 2 point, you can plot that point, and then you can just graph them. Here is another point that you can graph, and you can do it. You can pause a video, graph them, and then if you can graph them, you can bring that to the Q&A session so that we can go over that. And find the slope of the line passing through the point 2, -1. Then you have another point 2, 4. And it's exactly the same principle, same idea, and use that the slope equal to change in y over change in x, and you plug it in your y2 point is 4. 4 minus -1 is equal to +1, and then 2 minus 2 is equal to 0. So for this case, it's undefined. When the slope is undefined, doesn't mean that you have nothing. When the slope is undefined and you get the vertical slope, you get the vertical line, there's no slope to that. When you deal with vertical, there's no slope to that. And okay, so, and now you can pause that video, solve that, find the slope using that formula, m equal to y2 minus y1 divided by x2 minus x1. And then you're going to get the fraction. So let's talk about the parallel and perpendicular. So let's understand what is the parallel and what does the perpendicular mean. So when we say parallel, that means you have two lines that is parallel to each other. They're not going to intersect. They're not going to touch each line. When we talk about the perpendicular, perpendicular is the line that is going to be 90 degrees to the horizontal. So you're going to have a 90 degrees to the center, to the horizontal line. So first thing, to find that point, and if you find that this point, the slope passing through the point, you can just set that up, the m equal to y2 minus y1, x2 minus x1, and then you plug in that point, and now you can see the change that sign to plus, and then when you solve it, and now you can see your numerator turn that into 0. When the whole slope is equal to 0, then you know when the slope equal to 0, that means you're going to get the horizontal slope. That means you have a pretty flat slope. There's no slope to that. So a flat slope when the slope is equal to 0. And when the numerator equals 0, then yes, it's going to be a flat slope. When the denominator equal to 0, that means your line is going to be undefined. That means it's a vertical. There's no slope, but it's vertical slope. So here, between the slope is 0, we can expect the point to form a horizontal line as shown. So as you can see, And when you have the 2 point at the very at the flat slope, then you're gonna get a horizontal line. So here you can pause that video and then work on this 2 point and then find out what the line is gonna look like. And to me, and since the y2 minus y1 is equal to 0, and you know it's gonna be, this slope is gonna be 0, so you know it's gonna be a horizontal slope. When the slope is equal to 0, that means the flat is a flat slope, and it's going to be a horizontal slope. So for parallel, let's try to understand what's the parallel, what's the perpendicular. So when you have the same slope, when the first equation have the same slope as the second equation, then you know the line is parallel. And here's that slope of the parallel lines. So always remember, when they have the same slope, that means this equation is going to be parallel. But in the other, on the other hand, when both slope they're not the same and is opposite and reciprocal to each other, so you know that must be perpendicular. So let me try to make that clear one more time. So when it's a parallel, you're gonna get the M1 equal to M2. When it's perpendicular, you're gonna get M1. So your slope is gonna be opposite and reciprocal of that first slope. So when you see that formula, you know that that line, both equations gonna be perpendicular to each other. Again, perpendicular when the first line is at the right angle to the horizontal line, you call that a perpendicular line. So, or if you cross multiply this M1 and M2, then you're gonna get -1 to that. So here, and suppose you have a line has a slope of -6. So now they want you to find the slope that is parallel to that line. So the definition says when you have if you want to get the parallel line, the slope has to be the same. So when the first slope is given by -6, that means the second slope is also equal to -6. Therefore, they're both equal to -6 in order to get, both equation parallel, or two lines parallel. And to find the slope of the line perpendicular to the line with a given slope, find the slope of the line perpendicular to the line with a given slope. So m is equal to +1/6. So you always remember opposite and reciprocal of the slope is going to be the perpendicular to that given slope. So here is, you can pause that video, think about it, and pretty straightforward. When they ask you for the parallel, you know it's going to be the same slope. When they ask you for the perpendicular, you know it's going to be opposite to that and reciprocal for that. So opposite for that is negative, whatever that fraction is, but then you have the reciprocal of that, it will be 3/5. So the perpendicular for that slope is -3/5. Here we have a line, we have first line is L1 and the second line is L2, given the 2 point to both lines. Now they want you to determine if the L1 and L2 are parallel or perpendicular or neither. So I'm going to start with the first one. First one, I'm going to have to determine what the slope for the first line, and I'll do the same to find out what's the slope for the second line. So for the first line, and I'm substituting change in y over change in x. I'm going to substitute y2 minus y1. As you can see that numerator, 1 plus 7, and you get 8/2. And you do the same thing for m2. And now that when you simplify that, you get m1. Now let's look at m2. M2 do the same thing, change in y over change in x. And then when you simplify that, you're going to get -1/4. As you can see, the slope and you have a second slope is opposite and reciprocal for that slope, opposite and reciprocal for that slope. Now you know it must be perpendicular. Again, because the second slope is opposite and reciprocal of the first slope. Therefore, that line, these lines are perpendicular. Okay, let's look at, now you can find it out. If you have this two line again, and they want you to find out if it's parallel, perpendicular, or neither, so you're gonna have to do the same thing. First, you find out what's the point for L1, and then you find out what's the slope for L2. Then again, by definition, if it's the same slope, then must be parallel. When it's opposite and reciprocal for the first slope, then you know it's going to be perpendicular. If none of the above, then it's neither. So, and I'm going to have to, you can pause that video, try to solve it, and then you tell me if the slope is parallel, perpendicular, or neither. So let's look at one of the application of the slope, rate of change. So here, and let's say we have a annual median income for the males in the United States for a certain year is shown in the figure, and the trade is approximately linear. They want you to find the slope of that line, interpret the meaning of the slope in the context of the problem. So with given that 2 point, 2,000 comma that 28,300, and then you have 2008 comma that. So I'm gonna establish 2 point. So the first point is 2,000 comma that, and then the second point is 2008 comma whatever the number that is given. Now with the 2 point, I'm gonna use the same formula, which is m equal to change in y over change in x. With that, I can just subtract that. You use that point, subtract that 28,300 from 35,300, and you can do the same thing, subtract 2008 minus 2,000, and then you simplify that to get 875. 875. So the slope is 875. So that means the median income in the United States increased at the rate of 875 per year during the time period. So okay, with that, you can pause that video and solve this problem, and then bring that to the discussion session when we meet in the class. And for that, I'm gonna end this video. And let's move on to the next video for section 3.4.